Good morning, my dear students. So, today we are going to start the unit first order differential equations, that is a differential equation in which, and in this unit we are only discussing about the equation which contains only one dependent variable and only one independent variable. So, let us start with some basic introduction about the differential equation. So differential equations are very important in engineering, physics, economics and other disciplines. They arise in many areas of sciences and technologies. Differential equations are mathematically studied from several different perspectives. Rather, differential equation plays a very important role in different mathematical models. So basically, what is the differential equation? Let us start with the definition of differential equation. Let us start with the definition of differential equation. An equation involving one dependent variable and its derivative with respect to one or more independent variable is called a differential equation. Now, what is meant by the dependent variable? Suppose y is equal to f of x is the function, then this x is what? Independent variable, and this y is what? My dependent variable. Okay, so an equation involving one dependent variable and its derivative with respect to one or more independent variables is called a differential equation. So what is the differential definition? Equation involving one dependent variable and its derivative with respect to one or more independent variables is called a differential equation. Is called a differential equation. That is, for example, the differential equation contains dependent variable, its derivative with respect to one or more independent variables. So any equation if contains these terms, then we say that equation is nothing but a differential equation. For example, dy by dx is equal to kx. This is first one. X square y double dash is nothing but second derivative of y double dash is nothing but d2 by dx square of, that is the second derivative of y double dash minus 5x y dash plus 2y is equal to 3 to the power x. Third one, 1 minus x square d2y by dx square bracket cube minus 2x dy by dx is equal to 3y. This is again another example of what? Differential equation. So these are some examples of a differential equation. Now similarly we have the partial differential equation. This is what? This is the definition of ordinary differential equation, which contains only one dependent variable and only one independent variable. Okay, so this is what about the ordinary differential equation. So this is the definition of ordinary differential equation. Now similarly we will see what is the definition of partial differential equation. Next definition is what? Partial differential equation. What is mean by the partial differential equation? A partial differential equation, a partial differential equation is a differential equation in which y depends on two or more independent variables. Two or more independent variables, namely x, y, t, z. So, or that is, it is an equation. It is an equation of x, y, t, z and its partial derivatives like dou y by dou x, dou y by dou t, dou y by dou z, dou 2y by dou x square, dou y by dou x dou t, dou y by dou t dou z, like this. So these are the some examples of the partial differentiations. Now we will see an examples of the partial differential equations. Examples of the partial differential equations. First example is dou 2y by dou x square plus dou 2y by dou z square is equal to x plus z. Dou y by dou t is equal to k into dou 2y by dou x square plus dou 2y by dou z square. So these are the some examples of the partial differential equation. In this chapter we will discussing only about the ordinary differential equation. So the background for this chapter, in the background of this chapter we have to discuss about some basic definition. So some basic definitions about the ordinary differential equations are basic definitions. Basic definitions. So first one is order of a differential equation. First one is what is mean by order. The order of a differential equation is the order of highest derivative in the equation. That is, the order of differential equation is the order of highest derivative term. Order of differential equation is nothing but the order of the highest derivative term. That is, suppose a differential equation dy by dx plus d2y by dx square plus y square plus 3y cube is equal to 0. Then what is the order of that differential equation? The order of this differential equation is 2, because the highest order derivative term, that is the highest derivative, is what? 2. So the order will be 2. So order is nothing but the highest order derivative. Highest order derivative. Here not term, only we can say highest order derivative. Next definition is degree of a differential equation. So what are the basic use of these terms? In order to define the linear differential equation, linearity, in order to define the highest order or nth order differential equation, we need to know about this concept. So the degree तर ऑर्डर ऑफ डिफरन्शियल इक्वेशन म्हणजे काय? जर या डिफरन्शियल इक्वेशनमधली जी हायेस्ट डेरिव्हेटिव्ह टर्म असते, मॅक्सिमम डेरिव्हेटिव्ह जो असतो त्याला काय म्हणतात? ऑर्डर ऑफ दॅट डिफरन्शियल इक्वेशन. काय ऑर्डर ऑफ डिफरन्शियल इक्वेशन म्हणजे एखाद्या डिफरन्शियल इक्वेशनमधील त्याचं जे मॅक्सिमम डेरिव्हेटिव्ह असतं, समजा इथं थर्ड डेरिव्हेटिव्ह असलं असतं तर त्याला काय म्हटलं असतं? पण थर्ड ऑर्डर डिफरन्शियल इक्वेशन. फिफ्थ डेरिव्हेटिव्ह असलं असतं तर त्याला काय म्हटलं असतं? फिफ्थ ऑर्डर डिफरन्शियल इक्वेशन. समजलं? तर ऑर्डर ऑफ डिफरन्शियल इक्वेशन म्हणजे काय? त्याचं जे मॅक्सिमम डेरिव्हेटिव्ह असतं त्याला आपण काय म्हणतो? ऑर्डर. सिमिलरली डिग्री, द डिग्री ऑफ अ डिफरन्शियल इक्वेशन, द डिग्री of differential equation is the highest power of the highest ordered derivative term in the equation which is free from radicals and fractions. Which is free from radicals and fractions if they exist. Okay, so what is the degree of a differential equation? Degree of a differential equation is the highest power. Degree of differential equation म्हणजे काय? हायेस्ट पॉवर. पण कशाची हायेस्ट पॉवर? हायेस्ट ऑर्डर डेरिव्हेटिव्ह टर्म. हायेस्ट ऑर्डर डेरिव्हेटिव्ह टर्म जे तुमचा हायेस्ट डेरिव्हेटिव्ह टर्म असणार आहे त्याची हायेस्ट पॉवर, पण ती पॉवर काय असली पाहिजे? फ्री फ्रॉम रॅडिकल्स अँड फ्रॅक्शन्स. म्हणजे ती स्क्वेअर रूटमध्ये नसावी, फ्रॅक्शनमध्ये नसावी, त्याला कन्वर्ट करायचं आहे. आणि जर कन्वर्ट होत नसेल किंवा असे एखादी टर्म नसेल तर त्या डिफरन्शियल इक्वेशनची डिग्री डिफाईन होत नाही. डिफरन्शियल इक्वेशनची डिग्री डिफाईन होत नाही. डिग्री कशासाठी डिफाईन नाही? पहिली गोष्ट, डिग्री काय पाहिजे? फ्री फ्रॉम रॅडिकल्स अँड फ्रॅक्शन्स. Degree is always free from radicals and fractions, and the degree of a differential equation is the highest power. Degree of a differential equation is the highest power of highest order derivative term in an equation which is free from radicals and fractions. So the general form of ordinary differential equation of order n is written as, so the general form of ordinary differential equation of order n is written as f of x, y, y dash, y double dash to so on n minus 1th derivative of y is equal to nth derivative of y. This is what the जनरल फॉर्म ऑफ ऑर्डिनरी डिफरन्शियल इक्वेशन. कुठलेही डिफरन्शियल इक्वेशन जर जनरल फॉर्ममध्ये लिहायचं असेल तर आपण असं लिहितो. ठीक आहे. नेक्स्ट डेफिनेशन, व्हॉट इज मीन बाय द लिनियर डिफरन्शियल इक्वेशन. नेक्स्ट डेफिनेशन इज अबाउट लिनियर डिफरन्शियल इक्वेशन. Linear differential equation. What is mean by the linear differential equation? A ordinary differential equation. Ordinary differential equation म्हणजे काय माहिती आहे आपल्याला, की ज्या डिफरन्शियल इक्वेशनमध्ये एकच डिपेंडंट व्हेरिएबल आणि एकच इंडिपेंडंट व्हेरिएबल असतो. बरोबर. डिफरन्शियल इक्वेशन म्हणजे काय, ज्याच्यामध्ये इंडिपेंडंट व्हेरिएबल आणि त्याचे डेरिव्हेटिव्ह टर्म्स असतात, त्याला डिफरन्शियल इक्वेशन म्हणतात. मोर एव्हर ऑर्डिनरी डिफरन्शियल इक्वेशन म्हणजे काय, ज्याच्यामध्ये एकच डिपेंडंट व्हेरिएबल आणि एकच इंडिपेंडंट व्हेरिएबल. ऑर्डिनरी डिफरन्शियल इक्वेशन इज said to be linear if capital F can be written in the following form. Can be written in the following form. an of x nth derivative of y plus an minus 1 of x n minus 1th derivative of y plus up to so on a1 of x into first derivative of y plus a0 of x into y is equal to g of x. So this is what about the linear differential equation of order n. Linear differential equation of order n. For example, now from this definition we can have an immediate remarks about the linear ordinary differential equation. We will see that